In this video we're going to talk about how to make Lewis dot structures for a simple molecule. So we're going to talk about how you can illustrate that electrons are being shared in a covalent molecule. You can determine how the atoms are arranged in the molecule. You can determine whether single, double, or triple bonds are going to be needed. And you can figure out what the charge must be and illustrate why some covalent compounds must be polyatomic ions with extra electrons or more, or electrons removed compared to what you might expect. What is a Lewis dot structure? A Lewis dot structure is a simple representation of an atom or molecule and how its electrons are arranged, and it's a flat blueprint of the molecule. In the Lewis dot structure, what the dots represent are valence electrons. So the valence electrons are arranged into bonding pairs and non-bonding pairs. A bonding pair are two shared valence electrons that make the covalent bond between the atoms. So you will know that this is a bond because it is placed between two atoms and it shows that those are bonded. Non-bonding pairs are pairs or two valence electrons that are not involved in bonding, and we'll recognize those because they are placed around the atoms, not in between them. For example, a fluorine atom has 7 valence electrons, which means we're going to put 7 dots, and we arrange these dots into pairs around the north, south, east, and west sides of an atom. So if we had 2 fluorine atoms, they're going to come together to make an F2 molecule. This is the F2 molecule. In the F2 molecule, there's going to be 7 valence electrons for each atom. So 7 times 2 means we can use a total of 14 dots in our Lewis dot structure. And when we arrange them in such a way, we find that there are 2 electrons that go in the middle. That makes up the covalent bond. And now we have 1, 2, 3, 4, 5, 6 non-bonding pairs of electrons. So if there's 2 in each pair, that means there's 12 non-bonding pairs and 1 bonding pair. So by sharing the bonding pair of electrons, each of the fluorines now thinks it has a full outer shell of 8. So if we look at how each of these atoms have their valence shells overlap, one of these bonding electrons came from the fluorine on the right, and the other one came from the fluorine on the left, but the layers or their valence shells overlap, so each of them counts both of the electrons as being part of itself, and so the fluorine on the right has 8 valence electrons, and by counting those 2 electrons again, the fluorine on the left thinks it has 8. So both atoms feel that they have a full outer shell, even though only 14 electrons are being used. So how can you make a covalent molecule? How do we do this Lewis dot structure? Step 1 is to determine which atom is the central atom. And it's going to be whichever element there's only one atom of, or if there are more than one single atoms, it's going to be the carbon. Carbon always goes in the center. Secondly, you need to arrange the remaining atoms around the center. If you have 2 or 3 atoms in total, it's going to make a straight line shape. If you have a total of 4 atoms, you're going to have 1 in the center and 3 on 3 out of the 4 sides, which is going to end up looking like a T-shaped atom. Or if you have 5 total atoms, that means 1 in the center and 4 on all 4 sides, which means it's going to look like a cross. And then when you arrange the electrons, you're going to put 2 valence electrons between any bonded atoms, so between each pair of atoms, 2 dots, and that represents a single bond. You're going to arrange the remaining valence electrons into non-bonding pairs. And you want to arrange them in such a way such that all atoms have a full valence shell according to the duet rule or the octet rule. And that bonding pairs, as we saw in the F2 molecule, they count twice. They count for the atom on the left and they count towards the atom on the right. And you can check your work in the end by counting the total number of electrons used, or the total number of dots, should equal the sum of the valence electrons from each atom. So if you add the number of electrons that each atom has as a single individual atom, and you add them up, that's the total number of electrons you can use. So here are some examples of each of the three shapes that we might see for a Lewis dot structure. So an example of a straight line would be F2, as we saw on slide 3, and it's just two atoms. Or if you have something like H2O, it's going to be H, H, and O in the middle to make a straight line. And it's going to look like this, where you're going to have O goes in the middle because it's the only single atom, surrounded by H's on two sides. We put 2 electrons to bond the H and the O on the left, 2 to bond the H and the O on the right, and fill in the remaining electrons available to us as non-bonding pairs. Hydrogen doesn't need any non-bonding pairs. As you can see on all three of these examples, none of the hydrogens have non-bonding pairs on the outside because hydrogen follows the duet rule, which means it only needs to have 2 electrons to have a full outer shell. A T-shaped atom will be made of 4 atoms total. So you have the central atom with an atom on the left, the right, and on the bottom. So it looks like a T. NH3 is a perfect example of this, where we have 3 atoms that make the top of the T and 1 to make the leg, and a non-bonding pair. A cross-shaped atom will look like a plus sign. So you have the 1 atom in the center and 1 on the left, the right, the top, and the bottom. CH4 is a perfect example of this. So the atoms end up making like a cross shape or a plus sign. So let's go through these rules using H2O as an example. Step 1, the 3 atoms will form a straight line with O in the center. Again, we know it's O because in H2O, the 2 is referring to H's. There's only one O because there's no number here, so we can assume it's a 1. The total number of electrons we can use, or dots, is 8. 1 for the first hydrogen, 6 for the oxygen, and 1 for this hydrogen makes 8. We need 2 bonding pairs to bond each of these hydrogens to the oxygen, and they're going to fulfill the duet rule for the hydrogen, as we just said, without the hydrogen needing further non-bonding pairs. So of our 8, we've only used 4 in bonding. The remaining 4 electrons are going to be non-bonding pairs on the oxygen, 1, 2, 3, 4, to fulfill the octet rule for oxygen. If you're not able to give each atom a full valence shell with the number of electrons you have, what that means is more electrons need to be shared. So you're going to need to make one of your bonds a double or a triple bond. For example, in CO2, you actually need 2 double bonds. So you have, here's one bond, here's the second bond in the double bond. And to the oxygen on the right, there's also a double bond, meaning 4 atoms are going to be shared between the carbon in the middle and the oxygen on the right. 4 other electrons are shared between the oxygen on the left and the carbon. So by sharing all 4 of the bonding pairs of electrons that make the double bonds, all 3 atoms in CO2 have full valence shells even though there's only 16 electrons available. Some atoms need to become ions, as we learned about in a few chapters ago, in order to have a full outer shell. This is also the case with some molecules. When you have more than one atom bonded together that needs to become an ion by gaining electrons or losing electrons, we call these ions polyatomic ions. Poly meaning many, and atomic obviously meaning atoms. So if you have a covalent molecule with too many or too few electrons to fulfill the octet rule or duet rule, it needs to ionize. Usually this happens because the total number of valence electrons ends up being an odd number. And when you have bonding pairs and non-bonding pairs, obviously that means, because pairs is 2, you need to have multiples of 2, which means you need to have an even number of electrons. So the rules for doing a polyatomic ions Lewis dot structure is the same. You're just going to take into account that it has lost electrons or gained electrons to fulfill the octet rule or duet rule. For example, let's look at the polyatomic ion nitrogen trioxide. So in nitrogen trioxide, that's NO3, there's 4 atoms. They're going to form a T shape with N in the center. We know this because N is the only thing that there's a single atom of. O, there's 3 of them, so O can't go in the middle. The total amount of electrons available is 23. We get this because we have one nitrogen that has 5, And we have 1, 2, 3 oxygens that each have 6. 6 times 3 is 18, plus 5 is 23 dots available. So we have an odd number, which immediately tells us that this is going to ionize. It needs to gain electrons or lose electrons in order to get an even number to have a full outer shell. So we could try doing this in different ways, but the best answer that's going to work out is that if we add one more electron, then we'd be able to have a double bond and 2 single bonds to make this a polyatomic ion. So I'm jumping ahead a little bit. So if let's put this together and we'll say it's a T shape, and we're going to end up making a single bond, and a double bond, and we would have lots of different non-bonding pairs, but we see down here we have 1 electron by itself. This is the odd electron. So the bottom oxygen needs 1 more electron to fulfill the octet rule. So once we fulfilled the octet rule by gaining 1 electron, we need to write up here a -1 charge. That tells the reader that when we drew this Lewis dot structure, we know that we have 24 electrons. NO3 only has 23 as we just counted, but we have this extra one because this is an ion, and we show the reader that we know it's an ion. It's not that we don't know how to count. We show it's an ion by putting this -1 sign up here. So the molecule is now a polyatomic ion. Hopefully this helps when figuring out the different Lewis dot structures and what their shapes are. Good luck!